for the second thing in this lesson has to do with increasing and decreasing functions. And it's something that we think we already know. Even if we don't know the definition, we can look at a graph and we can see, okay, this function, this graph or this function is increasing here, decreasing here. We're going to make things a little more precise in a minute with these definitions here. But let's just look at, on page 3, this graph right here. So the graph of a function f. And, okay, most of us could say, all right, the graph is the graph or the function is increasing from here to here, it's decreasing from here to here, it's increasing from here to here, it's constant or it's flat from here to here, and it's decreasing from here to here. Now what do we mean? We have to be a little more precise about what we mean by from here to here. Okay. We want to, when we say a function is increasing, that means the values of f of x are increasing as x increases. And the function is decreasing if the values of f of x decrease as x increases. And we want to say, be particular careful. It's not, we never really just say a function is increasing or decreasing. It's increasing or decreasing or constant on a particular interval. And that interval is always an interval on the x-axis. So we look here, when we say, we don't just say the function is increasing from here to here. We can say from here the x-coordinate is -4. Here the x-coordinate is -3. So we can say that f is increasing on this interval from -4 to -3. Okay. All right. Now, where else would it be increasing? Well, it would be increasing from this point to this point. The x-coordinate here is -1. The x-coordinate here is 1. That's on this interval. So it's increasing from -1 to 1. And that would be it. We usually use open brackets here when we give the intervals because we don't really want to say something is increasing at a point. So it really doesn't matter if you include the endpoints or not, but we usually just use open intervals here. We would say f is decreasing. Well, where is it? Well, it's obviously decreasing from here to here. That's when x equals -3 to x equals -1. And we can also see it's decreasing from this point to this point. That is the interval 3 to 4. And then we could say f would be constant, where from here to here, when x goes from 1 to 3. Now, it's important that you read that these are all intervals. Okay, we are not talking about points here. It's all about intervals. Okay. And if you go ahead and look at the definition, you can see that's basically how we've defined increasing and decreasing and constant on an interval. Now we have also have this concept of a local maximum and a local minimum. Those basically correspond to the peaks and valleys of the graph. To be a little more mathematically precise, we say if we have a local maximum at C, we're talking about x equals C, and we're saying that f of x is less than or equal to f of C for all x in some open interval containing C. That means you can take the point at C and draw a little interval around C, and then this holds true for all values of x in that interval. Same thing with a local minimum at C. That means f of C is less than or equal to f of x for all x in this open interval. Okay, we don't have to specify what open interval it is, but we can see, like here, this is a peak, so this would be a local represents a local maximum. We would say we'd have a local maximum at x equals -3. Okay, and the value, we would say the value is 2. Okay, basically we can take that, so because we can see that around some interval, certainly from here to here, 2 is greater than or equal to any value of f of x on this interval. We have a local minimum here. That's a valley. Okay, so we have a local minimum at x equals -1, and the value is -1. So we give the y value here without writing y equals. Okay. Now, technically, we would also say we would have a maximum here and a maximum here, because at 1, we can certainly find this is this represents the largest value of f of x on this interval. So we have a local maximum at x equals 1, and a local maximum at x equals 3. We could really say that there's a maximum at any number between 1 and 3 right here. Okay, so, and of course the value of this would be equal to 1. Okay, but normally we won't see this too often. This is these last two cases are sort of degenerate cases, and so we would just leave it like that. And we would just, so basically, a local max corresponds to a peak, a local minimum corresponds to the valley. And just remember, give the x coordinate first.